In this lesson, we're working on solving quadratic equations. And when you solve a quadratic equation, what you're really doing is finding where that parabola, where the quadratic, crosses the x-axis. So you're really actually finding the x-intercepts when you solve a quadratic equation. Okay, so one way that you can solve a quadratic equation is by factoring. Okay, so that's what we're going to do in this video. So the steps to solve a quadratic by factoring is you've got to start by getting the equation equal to 0. So like if you look at it and it has like an equals y, or if it's equal to some other number, then you've got to get it equal to 0. So if it's just equal to y, you can just change the y to a 0. If it was equal to a number other than 0, then you have to move those numbers to the other side so that it does equal 0. Okay, so that's the first thing. Once you get it equal to 0, then you do the factoring part. Okay, so this is kind of what we've done in days prior to this. So remember, factoring, you always check for your greatest common factor first. Then you look, is it a binomial? And if it's a binomial, you're going to see if you can factor it with the difference of perfect squares. And then if it's not, and it's a trinomial, remember we talked about two different ways to do it. If it's trinomial, you'll use trial and error if the number in front of the x squared, or a, is equal to 1. And you'll use chin and grin if it's not equal to 1. Okay, and so we'll be reviewing factoring today. And then after you factor it, this is where the solving part comes in. Okay, so you actually, after you factor it, if you're actually solving it, then you have to do extra steps. Okay, so after you factored it, then you're going to take each of its factors, because remember the factors are going to be separated into parentheses now, and you have to actually take each one of them and set them equal to 0. And then you're going to have like a couple little mini equations, and then you solve those mini equations, and it will give you the solutions to that quadratic. Okay, so when does this work? Okay, the only time that you can solve a quadratic by factoring is if it can be factored, because remember, not everything can be factored. So if you try to factor it and it doesn't work, then that means you're going to have to solve it using a different method. Okay, so there are several different ways that you can solve a quadratic. This is just one of them. Okay, so we're going to go through a couple examples so you can see how these steps work in action. All right, so I'm just going to go through the steps. So with this first example, I look at it, I notice it's a quadratic equation, and the directions will say something like solve, or it might say find the x-intercepts, or it could, because remember, x-intercepts are also called roots, or they can be called zeros. So if it's asking for anything like that, you can solve it or try to solve it this way. Okay, so make sure the equation's equal to 0. So when I look at my equation, it's already set equal to 0, so I'm good there. Then if I'm trying to solve it by factoring, I'm going to try to factor it. So I'm going to look at the part on the other side from the 0. Okay, so I'm going to be looking at this part right here. And I'm going to say, okay, does it have a GCF? Do these terms have anything in common? And no, there's not anything that they all have in common besides 1. And so it doesn't really have a GCF I have to factor out. Then I'm going to look, is it a binomial? Does it have 2 terms? Or is it a trinomial? Does it have 3 terms? And it has 3 terms. So that means I'm going to factor it with what we talked about with the trinomial stuff. So as to whether it's just going to be a regular trial and error, or if I have to do the chin and grin part, I'm going to look in front of the x squared and notice there's a 1 in front of it. So that means I do just the regular trial and error. Okay, so that's where you put your 2 parentheses. And then with this part, that equals 0 just comes down with it. And then I factor. So what times what gives me x squared? It'd be x and x. And then remember with this, we look at our signs. So we start by looking at the last sign. And if it's negative, remember that meant our signs are going to be different. So that means one's going to have a positive and one's going to have a negative. And so because this is a basic one, I can actually go ahead and put my signs in there. And then I list out what's going to multiply to give that last term. So I've got 4 and 1, 2 and 2. Okay, and then this is where the thinking comes in. So which of these will combine with different signs to give you a positive 3? Well, notice if I take 4 and 1 and I take a positive 4 minus 1, I get a 3. So the 4 has to go with a positive, and then the 1 has to go with a negative. And then it's factored. And then remember, if you need to check this to make sure that you didn't make a mistake, you can always multiply it out, and you should end up with that. Okay? So after you factor it, if you are solving it, if it tells you you have to solve it, then that means you have to do extra steps. So don't forget to do the extra steps, okay? So after you have factored it, this is how you solve it. So you set each factor, so that's a factor of it, that's a factor of it. After you factor it, you're going to set each of those factors equal to 0. So that means I have to go to the side, and I'm going to take x plus 4 and set it equal to 0. And actually, you don't have to put the parentheses anymore, so I'll get rid of those. And then you're going to take the x minus 1 and set it equal to 0. Okay? So you set each factor equal to 0. And that's called the zero product property. So if you ever see that, that's what that is. And then you just have to solve those little mini equations. So to solve this one, I'm going to have to subtract my 4 to get the x by itself. So x would equal negative 4 here. And then here I'd have to add 1. And so x would equal positive 1 there. Okay? So those are the solutions to that quadratic. Okay? So like I was saying earlier, this would actually be where that quadratic would cross the x-axis. So you could actually take this and sketch a graph of it. So remember from earlier, we talked about if the number in front of the x squared is positive, it would open up. So if I sketched a graph of this, I would know it opens up, and I would know it crosses the x-axis at negative 4. So I'd go to negative 4 and put a little dot. And then I know it crosses at 1 on the x-axis. And so now this is going to be a very rough sketch, but you can at least kind of know a little bit more about what that would look like. So it would look something like that if you sketched a graph of it. And so remember, these are where it crosses the x-axis, okay? So your solutions to that problem, or x-intercepts, or roots, or zeros, they can call them all kinds of different names, would be negative 4 and 1. Okay, so let's do a couple more examples, just practicing finding or solving it by factoring, and then we'll look at some different types of questions they could ask you. Okay, so the next one, is it equal? You have to solve it, so you got to see if it's equal to 0, and notice it's equal to 0. Then you factor it. It's got 3 terms, so we're going to do the trinomial stuff. So look, does it have a 1 in front, or does it have some other number than 1? And it has a 1, so we're going to kind of do it like we did the other one. So I'm going to put my 2 parentheses. And I already checked for a GCF. They didn't have anything in common, so we're good there. And then you factor what times what gives me x squared. It'd be x and x. Then I look at my last sign. It's a positive, so that means they're going to be the same. And then I look at that sign to know what they're both going to be. So if they're the same, that tells me they're both going to be a negative. So I'm going to go ahead and put my negatives in there. And then you go to the side and you list what's going to multiply to give you this number. So we got 10 and 1, 5 and 2. Okay, from there, you kind of keep in mind what kind of signs they have. They're going to have the same sign. So that means when they have the same sign, that means you're kind of adding them. So which of these, when they both have negatives, will combine to give me a negative 7? That's what you're looking for. So notice the 5 and the 2. If I take negative 5 minus 2, that gives me negative 7. So That's the factored form of it. Now we have to actually do the solving part. So you take each factor and equal it to 0. So I'm going to go to the side, and I'm going to take x minus 5 and set it equal to 0, and then x minus 2 and set it equal to 0. Okay, then you solve. So I have to add my 5 here to get the x by itself, and x would equal 5. And then I have to add my 2 here, so x would equal 2. So those are the solutions to that quadratic equation. So you would write x is equal to, and I usually put them in numerical order, so x is equal to 2 and 5. And then again, you could take this and sketch a graph. It would open up because the number in front of x squared is positive, and then it would hit the x-axis at 2 and 5. Okay, so you could at least sketch a graph. All right, so let's do another one. What if we had to solve this one by factoring? So if I was solving this one, same thing, make sure it's equal to 0, and it is. Look for a GCF, doesn't have anything in common, and then is it a binomial or a trinomial? This one's only got 2 terms. So that means I'm going to see if I can factor it with the difference of perfect squares. Okay, so remember, difference of perfect squares, this has to be a perfect square, that has to be a perfect square, and you have to be taking the difference of them. And so notice that's a perfect square because the exponent is even. That's a perfect square, and you're subtracting them, so it is the difference of perfect squares. So to factor it, you put your 2 parentheses. Then what times what gives me x squared? It'd be x and x. And then remember, to get that negative sign, you actually have to have different signs. So kind of like what we talked up here. If it's got a negative as the last sign, it's going to be different. And then what times what gives me 49. So in other words, square root 49, and you get 7 and 7. Okay, and then just like before, just bring the equals 0 down. Okay, so you factored it. Now, to solve it, you set each factor equal to 0, and then you solve those equations. So for this one, I'd have x plus 7 equals 0, and then that one would be x minus 7 equals 0. Okay, then you solve. So here I'd have to subtract 7, so x would equal negative 7, and then here I would add 7, and then x would equal 7. Okay, so the solutions to this problem, I'll have to, actually I could squeeze it in right here, would be, it's going to cross the x-axis at negative 7 and at 7. So let me box in my answer here. Okay, so there we go. And again, you could sketch a graph. This would open up, and it would cross the x-axis at negative 7 and 7, and then you could at least sketch a graph. Okay, so the next one. All right, so if we still have to solve it by factoring, first goal, make sure your equation's equal to 0. Notice this one is not equal to 0. So that means I have to do a step before I can start the factoring part, okay? So you've got to get this to the other side so that it is equal to 0. So notice it's a minus 2x, so all you have to do to get that to the other side is add it. So when you add it to this side, you also have to do the same thing to this side. And so when I do that, these will go away, and I will end up with 0 on this side. And then I have to, notice this isn't a like term with anything, so I'm going to write this in standard form so that I can go ahead and factor it right after that. So the 5x squared is going to go first. Then that would be the next term, so it would be plus 2x, and then that minus 3 will go at the end. So minus 3. And then notice it's equal to 0 now. So now you can factor it. Okay. So is there a GCF? Do they have anything in common? And no, they don't have anything in common. So then I'm going to see, is it a binomial or trinomial? And it's a trinomial. And then I'm going to say, okay, is the a, the number in front of x squared, equal to 1 or not? Notice that one's not equal to 1. So this is one that's a chin and grin problem. Okay. So you draw your 2 parentheses, and then don't forget, for these problems, you've got to bring that equals 0 over. So don't forget to do that because you have to actually solve it at the end. Okay, and then This one you have a little bit more work to do. So for this one, you write down what multiplies to give you the first one, which is 5 and 1. And so that's it for that one. And then this would be 3 and 1. And then remember, you also have to do 1 and 3. You have to reverse it for the chin and grin problems. Then let's look at our signs. The signs will be different. So remember, you can't put that in yet, but just remember that they're different. So this one only has one factor. So you can go ahead and put that in. But this one you're going to have to figure out, okay, which combination would it be, 3 and 1 or 1 and 3 that works here? So you just try one, and then you do the chin and grin to see if it works. So you got 3 times x, which is 3x, 5 times 1, which is 5x. Then you have to think, okay, they're going to have different signs, and these have to combine somehow to give me a positive 2. So do these combine somehow to give me a positive 2? And they do, because if you put the plus sign with the 5 and the minus with the 3, if you combine those, you get positive 2x. So that works, but then you remember, you got to figure out the signs. So these were what you multiplied to get that. So the negative would go there. And then here, that positive would go there. So that is the factored version. So we factored it, so I can erase this now. So I'll erase. And then we solve it. So we take each one of these and we set them equal to 0. This is the solving part. And then you solve. So here I'd have to add my 3. So I'd have 5x equals 3. Then I'd have to divide by 5. So x would equal 3/5, which is okay. It's okay to get a fraction. And then here I'd have to subtract 1. So x would equal -1. So my answers would be x equals 3/5 and -1. That's where it would cross the x-axis, okay? So we got 2 more questions. The reason I'm doing these is because sometimes they ask you different types of questions, and I don't want you to get confused, okay? So first off, it says to solve it, so we're going to do this kind of like the same way. So you got to get equal to 0. It's not equal to 0, so I'm going to have to get it there. So I'd have to add my 15. So if I added my 15, that would go at the end. So I'm going to put plus 15 at the end. So now it's equal to 0. Then I'm going to factor it. So does it have a GCF? Well, they don't have anything in common, so I'm good there. It's a trinomial, and notice it's an easier one. So because it's got a 1 in front, so we're just going to do regular trial and error. So what times what gives me x squared? It'd be x and x. Notice this tells me the signs are going to be the same, and that tells me what they're both going to be. So if it's a plus, you look at this to know what they're both going to be. So they're both going to be a positive. Then we list out what multiplies to give me 15. So we got 15 and 1. We got 5 and 3. And then I think that's it. So which of these, if both of the signs are positive, will combine to give me 8? Well, if I take 5 plus 3, I get 8. So there's that. Then you take each of those and you set them equal to 0. So it'd be x plus 5 equals 0 and x plus 3 equals 0. So here you would subtract 5. So x would equal -5. And then here you would subtract 3. So x would equal -3. Okay. So your x-intercepts would be -5 and -3. Okay. Now, this next part of this, so notice in part B, it says, what is the horizontal distance between the zeros? So remember, another name for zeros, it's the same thing as x-intercepts, and that's actually what you're finding when you solve it. So what they're asking you is, how far are these two apart from each other? So remember, when we sketch a graph, so if I sketch a graph of that, it's going to open up because the number in front of x squared is positive, and it's going to cross at -5 and -3. So 1, 2, 3, 4, 5. It's going to cross right there, and it's going to cross right there. So if I sketched a graph of this, let's try that again. So if I sketched a graph of this, sorry guys, it would look something like that, right? And so they're asking you horizontal distance. Horizontal is this way. And so they're looking at how far those are apart from each other. So just sketch a graph and count. How far is this from that? And it's just 1, 2. So the horizontal distance is 2 units. So you just put 2, okay? So I just didn't want you to get confused with that, okay? So if they ask you something like that, sketch a graph and then just count, okay? So the last type of question that has thrown people off is something like this. It says, what are the zeros? So remember, zeros are the same thing as x-intercepts, which is what you get when you solve it. So notice in this one, they've actually already factored it for you. So all you have to do, like I said, this is the solving part right here, is where you take each factor and set it equal to 0. So if it's already factored for you, you just take those factors like we did in those last couple steps, so like that, and you set it equal to 0. Then you take this one and you set it equal to 0. Yes, it does look different. It's okay. I don't know why I'm putting the parentheses there. And then you solve them. So here we just have to add the 3. So x would equal 3. And then here we have a couple things to do. Or notice if you kind of look ahead, you could just add this x to both sides and you will notice that it saves you some time. So when I do that, these go away. You get 4 on this side, and then 0 plus x is just x. So if you realize that, you would already have your answer. Okay, so your x-intercepts here, or the solutions to this problem, would be 3 and 4. So there you go. So that is how you solve by factoring.